All right, we've reached the end of chapter 3. We're going to study section 311 in one video, and it's all about the hyperbolic functions. These functions I mentioned to you guys. I better get my drawing thing going on here. All I have is red for some reason. All right, cool. So what is a hyperbolic function? In class today, we were talking about it, and there are definitions. These guys occur in engineering a lot of times. And so let's write it. It's based upon the natural exponential function. So for example, COSH of x stands for hyperbolic cosine. There's a reason for all these names. It's defined to be e to the x plus e to the minus x over 2. These have been designed, okay? This other guy, SINH of x is really stands for hyperbolic sine. It's another function. It's very similar. It's e to the x minus e to the minus x all over 2. And the rest follow. So for example, hyperbolic tangent of x is hyperbolic sine of x over hyperbolic cosine of x. Of course, the abbreviation for these guys, by the way, is cosh x and sinh x. Those are just ways of just not having to say all hyperbolic cosine and all. So cosh and sinh, who cares? So when you put one on top of the other, what you've got is, well, let's write it 1/2 e to the minus x minus e to the, oops, blew that, e to the x minus e to the minus x, all over 1/2 e to the x plus e to the minus x. So hyperbolic tangent is really e to the x minus e to the minus x divided by e to the x plus e to the minus x. Okay. Why study these guys? Good question. Here they are. I was telling folks in the class earlier today that, for example, the so-called catenary, which is really, I think it gets translated as like a hanging chain. In other words, if you have a post and another post and you hang wire or chain or rope, heavy rope, it forms a curve. And that curve is not a parabola. That curve is based upon, believe it or not, it's based upon the hyperbolic cosine of x curve. You just mess with the coefficients outside and inside, and you get whatever hanging curve you want. A famous one is in St. Louis, Missouri, but it's upside down. And you guys know what I'm talking about? Yeah, that's the Gateway Arch. The gateway to the west, and it is actually based upon the hyperbolic cosine function. It's very sturdy as a result, so it's in a lot of engineering applications. Okay, names, applications, definitions, all that stuff. That's this page. You have others. You have the hyperbolic cotangent of x. You got hyperbolic secant of x. And the last one is hyperbolic cosecant of x. Let's see. What's next on this page? Okay, derivatives. The thing about it is the reason they're called hyperbolic is you can show that hyperbolic cosine squared of x, and you take hyperbolic sine squared of x, and we did this in class. What happens is if you subtract them instead of add them, you get 1. Compare it to what we call the circular functions. That one is, you've got, if you take cosine squared, this is trig, and you add to it sine squared, you get 1. That's Mr. Pythagoras, right? Well, if you think of this as an equation like cosine is x and sine is y, like on a unit circle, you get a 1. So this is a circle of radius 1. That's the unit circle. If you did the same thing here, x squared minus y squared is 1. That's a quote-unquote unit hyperbola. Hence the name hyperbolic functions. They've got a lot of properties, just like the trig properties. It's a very clever family of functions. And there you have it. So that's an introduction to these guys. Let's look at their derivatives. So for example, someone says, take the derivative of hyperbolic cosine. Okay, I will. What I do right away is say, all right, we're really deriving 1/2 e to the x plus e to the minus x. Something interesting happens. What you end up with is, oh, that's equal to 1, we're deriving now 1/2 e to the x again, right? Derive e to the x, still get it? Here's a tiny little chain rule. E to the minus x times derivative of minus x is, well, I'll say it that way. E to the minus x times minus 1 from the chain rule gets you 1/2 e to the x minus e to the minus x. You know what that is? Sinh, or sine hyperbolic of x. So that's a weirdness. The derivative with respect to x of cosh is sinh. And the derivative with respect to x of sinh, you can do this if you want, is cosh. Even nicer, more friendly than the trig functions, because remember with trig, the derivative of cosine is negative sine, not regular sine, so that's the way that goes. Let's do one more for fun. What's the derivative, say, of hyperbolic tangent of x? Well, on the previous page, we come up with a formula for it, so it's e to the x, etc. So really what we're doing is we are deriving with respect to x e to the x minus e to the minus x all over e to the x plus. All right, so I think what we need here is the quotient rule. So it's equal to the bottom, e to the x plus e to the minus x squared. Bring it up, e to the x plus e to the minus x. Derivative of the top, e to the x. Here comes another negative. Do you see it? It's going to be minus e to the minus x times minus 1. So it actually becomes plus e to the minus x. Weird, huh? Good design. Minus the top, e to the x minus e to the minus x. And downstairs, and then we derive the downstairs. We've done it before. E to the x minus e to the minus x. This is correctly done. Okay, so upstairs we get, oh boy, this is a pre-calculus problem. Foil this out. Foil this out. All right, we get e to the 2x when we square that thing. This is interesting, watch. We get e to the x meets e to the minus x. That's 1. Here comes another one. So this is plus 2. And then plus e to the negative 2x. Okay, that minus this FOIL. E to the 2x minus 2 plus e to the minus 2x. And downstairs, same thing. I know that FOIL was quick, wasn't it? But look what happens. E to the 2x minus e to the 2x. E to the minus 2x minus e to the minus 2x. Answer, 2 plus 2, who wants it? See, it is. It's 2 minus a minus 2. So you end up with 4 all over e to the x plus e to the minus x quantity squared. Hey, and we're happy with that. That's the derivative. Ah, but wait, there's more. So the derivative, okay, let's continue this story. It's almost done. You can write this as something squared, namely 2 over e to the x plus e to the minus x. Okay, so that's the derivative of hyperbolic tangent. Still not done. Because, you know what this is? This is 1 over hyperbolic cosine of x. It flipped over, didn't it? You know what that's called? You got it. Hyperbolic secant of x. So yeah, what this means is when you derive tangent hyperbolic, you get secant hyperbolic squared, just like in trig. In fact, all the derivatives are the same as trig, only they're all positive. This is a perfect world. So derivative of, say, cotangent is no longer is it negative cosecant squared, it's hyperbolic cotangent derived is positive. Let me write it. So derivative with respect to x of coth x, hyperbolic cotangent, is hyperbolic cosecant squared x, and that's it. This section, this is a short video, but it's getting kind of long. This section on the inverse stuff, let's not do it. I was looking at it. I haven't done it in a long while, and there's a lot of algebra to it. It's cool to look in the book and see that it opens up others, but you guys don't have to worry about it. We're going to skip that one, the inverse hyperbolics. I usually do anyway. So I'm down to just 2 examples to show you. This is what the homework looks like. All right, so f of x is this function. We're supposed to find f prime of 0. That means find the derivative and plug in 0. Easy peasy. So we go f prime of x is, natural log means flip it over, times the derivative of x is just 1, chain rule, minus, here's some fun, 3. Okay, I've got an outer function of sinh now, not just sine, and then an inner function. Okay, so it's going to be derivative of hyperbolic sine is hyperbolic cosine, evaluated at stuff times derivative of stuff. That's the chain rule. And the stuff is just x over 2. All right, not to belabor this, what we have is 1 over x plus 3. We've got a minus 3 cosh of x over 2 times derivative of this guy is 1/2. So let's clean it up. It's 1 over x plus 3 minus 3/2 cosh of x over 2. Okay, so what is f prime of 0? Plug in and find out. So we're getting 1 over 0 plus 3 minus 3 over 2 hyperbolic cosine of 0 over 2. And we're getting a 1/3 here, minus 3/2. Here's the fun part about it. We're making you figure out what is hyperbolic cosine of 0. Well, that's equal to e to the 0 plus e to the negative 0. Well, that's 1 plus 1. Who wants it? Over 2. 2 over 2. It's equal to 1. So times 1. So our problem devolves into 1/3 minus 3/2, which I think I found out to be negative 7/6. You can check that last step. There's that. One more, you can pause it and stare at it. One more is this derivative. We did something very similar. G prime of x, what we need is the quotient rule again. And I'm just showing you stuff, hey, they're just having you derive and compute and things like that with this new family of functions. So we'll do it. 1 minus sinh squared, 1 minus sinh. Derivative upstairs, 1 goes to 0. Derivative of sinh is cosh. It's a sinh. Sorry. Minus 1 plus sinh. Derivative downstairs is, look at that, it's negative cosh. Because there's a negative in front, right? So we get cosh, I'm distributing now, minus cosh x minus hyperbolic sine x times hyperbolic cosine x. Better be proper here. Now when I derive and when I distribute that, I get a double negative, so it's plus cosh x. And then this is right there. That's a negative, and another negative is plus sinh x times cosh x. And downstairs is still waiting patiently, this guy. All right, look what happens. We have that canceling with that. We have two coshas added together. So we're getting this final answer of 2 over 1 minus sinh hyperbolic squared. There's nothing you can do with that. It is what it is. Thank you for your time on that. That's the end of our lecture series on Chapter 3. So now study, study. All right.